Okay, now in a photoelectric effect experiment, a light of wavelength 400 nanometer is incident on a metal surface which has a work function of 2 electron volt, not in joule but in electron volt. Okay? Calculate the threshold frequency and then the stopping voltage and so on. Let's look at first question first. Now what we have here is we have an incident ray. Here this is he said light of wavelength. So this is the incident photon. Okay, incident ray with this wavelength. So this is the lambda. Okay, but in nanometer you need to change to meter. Incident on the metal surface. Okay, on the metal surface, this is the work function W naught, but in electron volt. So we want to find the threshold frequency. So the question want to find threshold frequency. We know that different metal has different threshold frequency. Okay, so threshold frequency is F naught, and then we need to find the stopping voltage later on. Stopping voltage is Vs. Okay, let's do the question A first. So how to do it? If the question gives us lambda, we can find the energy of photon easily. Energy of photon, but lambda is nanometer. I change to meter. 400 exponent negative 9 meter. Metal surface has a work function 2 electron volt. Okay, we want to find threshold frequency. Okay, since we already have the work function W naught, okay, we can straight away find the threshold frequency. Because why? Because W naught equal to HF naught. Because the work function is equal to the work function is already equal to H times threshold frequency. So we can straight away find threshold frequency. But the thing is, this equation is the same like the equation before. Like it's the same as the equation before about the incident energy of the incident photon. Okay, as I said, this equation must be in joule because both sides is joule. Okay, the HF after multiply, the H itself is joule second, the F itself is per second. So the right hand side here is joule. So the energy we got here also joule. So same thing. This also is about this formula is also the same as this formula. Almost the same type. The work function is just like the energy, and then the HF naught is just like the HF. So both sides also joule. Both sides also joule. So what I can say is the work function he provide is in electron volt. You see that? Electron volt. So you can never do this. Electron volt straight away substitute into here, and then the E2 electron volt equal to HF naught. This is wrong. Don't do this at home and don't do this at the school. Okay? This is wrong. Don't straight away substitute into it. So what you have to do is you have to convert. First, you have to convert to joule. First, you have to convert this one to joule. How to convert to joule? Remember, you have learned before how to convert the unit again. Electron volt, these two units, electron volt and joule, they both are unit for energy. They both are units for energy. So to convert for electron volt to joule, we multiply. Electron volt to joule, we multiply electron. From joule back to electron volt, we divide. Divide electron charge. Okay, electron volt become joule. Is the electron alpha symbol become value. That's why we multiply electron. Now from joule go back to electron volt. We want to create the electron. We need to divide the electron lah. Understand? So but now we want to convert from electron volt to joule. Yeah, electron volt to joule. So it's electron volt to joule means we multiply electron. Okay, so we multiply electron. So how to multiply electron? This answer is 2.0 times electron charge is 1.6 exponent negative 19. Then you get the answer in joule. Okay, 2 times 1.6 is 3.2 exponent negative 19 joule. So the answer already in, the energy already in joule. Now you can do this lah. Now you can substitute into the formula safely. Sorry again, what happened to this software? Okay, so now you can substitute the work function in joule into the formula, work W naught equal to HF naught. So we will get 3.2 exponent negative 19 joule equal to H is a 6.63 exponent negative 34. You can find this in list of constant F naught. So what is your threshold frequency? Okay, what's our threshold frequency? The answer is 4.83 exponent 14 hertz. That's our threshold frequency. Okay, that's our threshold frequency. Different metal has different threshold frequency. Okay, so this is the threshold frequency. So we got the answer 4.83 exponent 14 hertz. Now let's move on to the next question B. Okay, next question B. So find the stopping voltage now. Yeah, find the stopping voltage. Okay, how to find the stopping voltage? Stopping voltage is actually related to the Kmax. Kmax equal to EVS. Okay, so stopping voltage related to kinetic energy of maximum, because we need the stopping voltage to stop the kinetic energy of the ejected electron. Okay, so which formula has Kmax? This formula, E equal to Kmax plus work function. Okay, E equal to Kmax plus work function. So do we have, so if we want to find the stopping voltage, we need to find Kmax. To find Kmax, we use the photoelectric effect equation by Einstein. Okay, so to find Kmax, we need the energy of photon. Do we have energy of photon? No, we only have the wavelength of photon. Okay, never mind. We can find the energy for photon by using hc over lambda. Yeah, let's find first. hc over lambda. hc over lambda, H is H is 6.63 exponent negative 34. You can find this value in the list of constant. The C is 3 exponent 8. And then lambda is, what is lambda? Lambda is 400 exponent negative 9. 400 exponent negative 9 meter. Already changed to SI unit. Yeah. So I don't have the answer with me, but you can calculate yourself. Okay, you can calculate yourself. So we can find the energy from here. The answer for this one is in joule. Remember, all in SI unit. All SI. All the formula you use must be in SI unit. The electron volt is we convert by ourselves. Whatever formula we use here, all in SI unit. Yeah, like this one, all W naught equal to HF naught, E equal to HF. Okay, so yeah, don't just forget about this one. Yeah, not related. Is is actually from here. Yeah, actually from here. Okay, so whatever formula like this one, W naught equal to HF naught, all this one is all in SI unit. All in SI unit. Yeah, so you this formula also lah, HC or lambda also we got in SI unit joule. So you got this in joule. So now we need find the Kmax, but we need the work function also. Do we have the work function? Yes, we already have the work function. We use the electron volt or we use the joule. We use which one? 2 electron volt or use the work function in joule? Of course in joule, because remember, if you use this formula, you must maintain all same unit. If you this one, you can either use all joule equal to joule plus joule. The energy for photon, Kmax, and the work function all in unit joule. Or you can also use all in electron volt. Yeah, they must be same unit plus with same unit. You cannot do something like this. You cannot say, oh, joule equal to electron volt plus joule. Cannot. This one cannot. This one cannot. You can all maintain at same unit. You want to have all joule, then all go for all joule. You want for electron volt, then all go for electron volt. Okay, don't mix it up. Don't ever mix it up. Okay, understand? Now, I will just want to rub this off. Okay, so now my answer for energy is in joule. So since this one in joule, I just use joule lah. I just use the energy in joule. So my work function, I also use joule. Work function, I also use the one in joule. Okay, also use the one in joule. So the kinetic energy I get surely in unit joule. Understand? Okay, so I don't know my energy, I got what answer, but you can calculate yourself. And then Kmax and plus work function. Work function is use the one in joule. Okay, in joule. So finally, my Kmax, I also don't have the answer with me. This Kmax, I got the answer in joule. Understand or not? Because all, even the energy also in joule. The energy here also in joule. This one also in joule. Okay, in joule. So my Kmax also in joule. Okay, Kmax also in joule. So, I got my Kmax in joule. This one also, remember Kmax equal to EBS. This one also in unit joule lah. This one also unit in joule. Because energy in joule. Yeah. So EBS also in joule. Okay. So I don't have the answer with me, but you can calculate. Okay, whatever equal to joule. Remember, this one also might be in joule unit. Equal to the E is the electron charge, 1.6 exponent negative 19. At 1.6 exponent negative 19. And then I get the stopping voltage. From this one, I can get the stopping voltage, which is equal to, and then I divide the kinetic energy with this electron charge, 1.6 exponent negative 19. I got the stopping potential. Okay, I got the answer for this, which is, the answer is, oh, actually I got the kinetic energy already. Yeah, the kinetic energy I got is, for this question just now, I got the answer is EVS is equal, Kmax is equal to 1.77 exponent negative 19 joule. Okay, because all in joule. Okay, this one, so I substitute the Kmax 1.77. Okay, this one just drag to the bottom here. Okay, yeah, just make, you want to have a messy work. Yeah, so yeah, okay, so my Kmax is 1.77. My Kmax is 1.77 exponent negative 19. Exponent negative 19. So now what is my Vs? My Vs is, I divide, I get my stopping voltage at 1.11 volts. 1.11 volt. Okay, that's my stopping voltage. However, the stopping voltage, the value you get here is only the value itself. But if you want to give the stopping voltage answer, you must include the negative sign. You must include the negative sign, which is, you must write the answer in Vs. So Vs is actually equal to negative. Negative, because why negative? Because it's a reverse voltage. So please remember, please give your answer in negative. Yeah, please give your answer in negative. The reason is, the negative means reverse, because when you want to apply a stopping voltage, you reverse the potential difference, you reverse the terminal. That's why the stopping voltage has a negative sign actually, but only in calculation, no negative. But in calculation, ignore the negative sign. Yeah, ignore the negative sign in calculation. In calculation, ignore the negative sign. But in the final answer for stopping voltage, if the question asks for for the final answer, if the question asks for stopping voltage, you must include you must include negative sign. Okay, the final answer for stopping voltage, you must include the negative sign, because that negative explains the meaning of stopping voltage. Yeah, because a stopping voltage is a kind of reverse voltage. Okay, you must include the negative sign. But in calculation, just ignore the negative sign. Okay, you don't have a negative sign here. Even the electron charge also ignore the negative sign. You see, both of these, they both have negative sign, but we ignore. Yeah, both of them, they have negative sign, but we ignore the negative sign. Okay, both of them. Electron charge also negative charge, but we ignore the negative sign during calculation. Okay. Now, let's look at the last questions. What is the energy? Okay, the energy of the incident photon for a light of wavelength 700 nanometer, and determine what will happen to the photoelectron on this metal. Okay, so calculate the energy. You want us to calculate energy for another wavelength. Okay, this is actually another wavelength already. And we put as lambda 2. Okay, this one energy, another energy already. This is energy 2 lah. It is energy 2, another photon. What happened with the photoelectron? Well, actually, what will happen to the photoelectron? This one will talk about, will the photoelectron be ejected or not? Actually, is this one lah. Actually, we are discussing about this phenomenon of photoelectric effect. So actually, the condition here is he asking whether this wavelength has enough energy, the photon has enough energy to eject the electron, or not enough energy to eject the electron. So we need to calculate the energy of the photon first and compare with the work function. Okay, so what I can say is, if the energy, this is the energy of photon, HF. If the energy of photon, more than the work function or equal to the work function, okay, more or equal to the work function, can be ejected. However, if the energy of photon is less than the minimum energy required, less than the work function, no electron is ejected. Okay, so that's what we need to compare. One way is to use the energy to calculate energy, okay, energy of the photon. Another way is just compare their threshold frequency and threshold wavelength. If the frequency of the incident photon more than the threshold frequency, or equal to the threshold frequency, can eject. Or we can say the incident photon wavelength less than or equal to the threshold wavelength, can eject. If the incident frequency less than threshold frequency, or the wavelength more than the threshold wavelength, cannot eject. So we have three ways to determine. Actually, we have three ways to see whether can eject or cannot eject. The three ways is we compare. We can use we can look at the energy of photon, or we can look at the frequency of the incident photon or the wavelength of the incident photon, and then just compare them. Just compare them with the threshold wavelength, threshold frequency, and threshold frequency, work function. Sorry, this is work function. Compare the frequency with threshold frequency, or compare the wavelength with threshold wavelength. So which one you want to use? You have three ways for you to choose. Normally, people will just use the first one lah. Find the energy. Or you want to use the frequency or wavelength to compare with the threshold frequency, threshold wavelength, also can. Yeah, also can. But normally people use the energy. Find the energy. So let us find the energy. Okay. There are three ways for you to determine whether can eject or cannot eject. Yeah. Okay. So I use the first one. Okay. Energy compare with the work function. So let's calculate the energy. This is the wavelength for second light. So let's find out the energy for this photon. for this new photon. Okay, so we have this h is 6.63 exponent negative 34, speed of light, and then wavelength is 700 nanometer, which is negative 9. Okay, already all in SI unit. Yeah, all in SI unit. Okay, SI unit. So the answer will be get joule. Yeah, energy will get joule. So what is the answer for joule? Yeah, I get it. It is 2.84 exponent negative 19 joule. So I already got the energy of the second photon in joule. It is 2.84. So if you compare with the work function, what is the work function? 2 electron volt. Oh, 2 electron volt. So I need to change my joule to electron volt. Actually, I also got the energy in joule already, work function in joule already, isn't it? Work function in joule, which is 3.2 exponent negative 19. So I look at compare. I just write it down. Work function. Okay, I just write it down. Work function equal to 3.2. Work function equal to 3.2 exponent negative 9. Is it negative 19? Yeah, 3.2 exponent negative 19 joule. So this is the energy of the incident photon. 2.84. Work function is 3.2. Which one is bigger? Is the energy of the photon enough to eject the electron with binding energy 3.2? 2.84, is it enough to overcome the 3.2? Not enough. So we can see the energy of the photon is less than the work function. Not enough energy. We can say it is the third case lah. The third case, the energy of the incident photon, not enough energy to overcome the work function, so no photoelectron will be ejected. Photons does not have enough energy to eject the electron. Okay, so you can say no photoelectron is ejected. No, no. No photoelectron. There'll be current equal to 0. The galvanometer reading, the galvanometer will no current at all. Yeah, the current will equal to 0 ampere. No current at all. No photoelectron will be ejected. So we can say because the energy of the incident photon is less than the work function. You must write this lah. Energy of the incident photon. Yeah, or you can also write the value there. Yeah. Once you write this, you must have you must include with the value. You must include with the value 2.84 exponent negative 19 joule is less than 3.2 exponent negative 19 joule. The photon does not have enough energy to eject electron. Okay, does not have enough energy to eject electron because the energy of incident photon is less than the work function. Write it down. Energy of photon of incident photon is less than work function of metal surface. Okay. Okay, so that's it for no photoelectron. Okay, that's it for these videos. Okay, let's move on to the next one.